All right, everybody. I think we're going to go ahead and get started. We got 44 folks on. I'm Josh Poduska. It's great to be with all of you today. This workshop, I've given it several times before. Pretty much every time I've given it has been at the Strata Data Conference, back when it used to be called other things as well. That conference is no longer around. For those of you that follow the conferences, you know that Strata is no longer. So I am excited for the first time to be presenting it outside of Strata at a new conference, the Toronto Machine Learning Society. I presented with them at their last conference, Model Ops Conference, and it was a great team to be working with. So very much looking forward to this presentation today. It's good content for managers, for data science leaders, executives, and also for team leads and aspiring managers as well. A lot of really solid content in here. And I'm very pleased to be joined by Randi today. So let me get started and we'll do a little bit of more formal introductions. I already mentioned my name. I'm the Chief Data Scientist at Domino Data Lab. I've been in the industry for about 20 years. About half my career I spent as a practitioner, about half as a leader. In my practitioner time, I worked on projects in the public sector, which was really exciting, really fun. Enjoyed that quite a bit, and also in manufacturing. As a leader, I've worked for several different analytical software companies, leading data science initiatives and teams. And Randi, I'll let you introduce yourself.
Yeah, absolutely. I'm Randi Ludwig. I'm a senior manager of applied data science at Dell. So I've been in the data science space since 2015, spent my first year breaking into the space doing consulting work, and then started out as a practitioner, um, converting into a full-time at Dell, and then now have been in a manager role for about a year, leading both the single data science team that I manage, as well as coordinating things for our entire 10 different data science teams in the services space of Dell. So getting to have kind of a bird's eye view of data science applied in many different teams with many different use cases. So.
Yeah, fantastic. Thank you so much, Randi, for joining us today, for joining me and presenting with me. I worked with Randi before, presented with her before. She's great. When I knew I was going to be presenting at this conference, she's the first one I reached out to, and thankfully she said yes. So very, very fortunate.
Happy to be here.
Randi. Yeah, great. This is also the first time I'm giving this workshop virtually. It's everything, not everything. Many things are better in person, workshops being one of them. So I'm hopeful that the benefits that attendees get out of this workshop will not be lost because it's virtual. To that end, I want to start by seeing if we can make things a little bit interactive. So here's the agenda. I won't read it, but can you in the chat, let's try using the chat, just say where you're from. Everybody just jump into that chat real quick and let us know where you are from. So I think you respond to panelists and attendees, I think is how it goes, or to everyone. All right, coming in here.
Shockingly, lots from Toronto.
Yeah. I saw Austin up earlier, Chicago.
London. Oh, London, Ontario. Didn't know there was a London, Ontario.
There we go. Toronto. From Dia. I'm from Sacramento. Was that you that was the Austin one?
Yeah.
Yeah, that was you. All right. We are from Sacramento, and
second best London in the world.
go Kings. That's right, Ruben. Okay, fantastic. So we will be using the chat. We'll probably just use the chat for questions and answers. You can use, there's a Q&A feature too in the webinars, and often it's hard to remember to look at both of them. We'll try our best to look at both. So let's just try the chat for questions as it goes. But please use that, and then we can, I think you're probably all muted. There might be a point later on where we'll have some questions for you. And maybe we'll try to unmute you as this goes on, but anyway, we'll try to figure it out. All right, so here's the breakdown. Introduction, motivation, and then we'll jump into process. After that, we have a breakout exercise, which will be not really a breakout, but just we'll all work on something together. And then we'll go into people. Again, at the end of that, we'll have a kind of collaborative exercise, which hopefully, fingers crossed, will go well. And then we'll talk about managing technology to wrap it up, and then we'll be able to have some questions at the end too if we don't get to them in the middle. But it would be great to have questions along the way too. All right, let's start out by setting the stage here and making sure that we are all on the same page with what data science is and why it is different and why we should care. As leaders of analytical organizations and teams, this is very important to be able to understand and articulate to other leaders, to executives, and to board members. So at the heart of data science lies an innocuous sounding thing called a model. And the most successful companies in the world run their businesses on models. You've all heard of Netflix. You've probably heard of the Netflix challenge, several years old now, but that recommendation model from Netflix is valued in the billions of dollars for one model. On a more operational side, you might not know that Coca-Cola Company also distributes orange juice, and the network of their distribution and their manufacturing of orange juice, where they get their source materials and how they service those across their different distribution plants, manufacturing plants, and then how do they spread those out to the distribution plants. That entire complicated network of very kind of down to earth nuts and bolts execution is all run on a model as well. The insurance industry is being transformed by models where you can take a picture of your damage and instantly get an estimate of the claim, and also have that picture and some of the information you enter on an app help streamline your claim for faster processing. Really, there are two main benefits of models. One is this big breakthroughs, the home runs, exciting new projects. Second is that underlying operational efficiencies that compound on top of each other over and over and bring immense value. Arguably, number two is more valuable to companies. It depends on the industry and what the company's goal is. This is a bit old now, but this is a great summary from Jeff Bezos in a letter to stakeholders from 2016 about these two benefits of machine learning. He says, at Amazon, we've been engaged in the practical application of machine learning for many years now. Some of this work is highly visible. Our autonomous Prime air delivery drones and Amazon Go convenience stores that use machine vision to eliminate checkout lines, and Alexa, our cloud-based AI assistant. But much of what we do with machine learning happens beneath the surface. Machine learning drives our algorithms for demand forecasting, product search rankings, product and deal recommendations, merchandising placements, fraud detection, translations, and much more. And this was 4 years ago. So you know that that list is growing tremendously by now. The nut is that companies that don't run their business on models face an existential threat. And all of you, because you're on this workshop, are a key part to those companies' survival, because you are leading teams or aspiring to lead teams that are helping those companies run on models, those companies and organizations, I like to say. Many studies have been done to show the benefits of running your business on models. One study by McKinsey found that 20% of companies have in the way they measured this, were running their business on models with significant numbers of models in production or significant parts of the business running on models. That 20% had a 7.5 profit margin increase compared to the industry average, while those that didn't had a 2.5% decrease, leading to a 10% difference between the haves and the have-nots for data science and analytical prowess. At Domino, we work with lots of companies all over the world, usually larger companies, but we work also with a lot of mid-sized players as well. And these are some really interesting quotes and some funny quotes that we've heard and we captured along the way from working with our companies. The first one here, it takes 6 months to get new packages, so I just secretly bring my personal laptop. We built our new headquarters faster than we got a model into production. And I know which company this is, and their headquarters is beautiful. And that is a horribly funny statement, but true. Knowledge management is so bad, every day is like my first day. And many other quotes, all pointing to the barriers that exist to managing data science effectively in the enterprise. A lot of this talk, this workshop, will be about how to overcome these barriers. Somewhat in summary of what I've been saying so far is an understanding of the model myth. The model myth is a misconception that because models involve code and data, they should be treated the same as software and data. That's an incorrect fallacy. And what we need to do instead is treat data science as an organizational capability. And if we can, both in our own minds and our team's minds and at an organizational level, start to treat data science truly as an organizational capability, that's when we start to really see the flywheel of data science start to spin and the benefits to the organization come. This is a diagram of what the world should look like. This is what we want our worlds to look like. Off on the left, we have the model development part of this world, the model development compartment, the researchers collaborating together on data science projects, overseen by many of you on this call, data science leaders. We have a validation and review process that sends the models into deployment, where we're now collaborating with IT with a clean handoff to IT and other systems owners. Risk and compliance have oversight and visibility into how this process works. Executives and leaders from other technology departments also have insight and oversight, as well as business leaders, and they can help with that monitoring and feedback loop. This is what we want the world to look like, but too often, this is what the world looks like. We have a slow, unclear path to development. Data science leaders have no idea what's going on. Well, not no idea, but I mean, I've talked to data science leaders before where I've asked, how many projects do you have in production? And they said, funny, I was asked that by my CEO about a month ago, and I had to go around the office, this is back before COVID, with a pencil and paper in hand, asking everyone, how many projects do you have? How many projects do you have, to get that list? It's really hard to get oversight sometimes into what's happening in the data science world, and production can be a black hole. Randy, I know when you and I were talking, you've seen some of this in the work that you've done, and you've, I think, developed what was it called, the Jedi Council, to help support some of this. Do you mind sharing a bit of that insight?
Yeah, absolutely. Actually, I was just thinking as you're talking about the level of detail that you just shared was not, we hadn't chatted about that before, but I've literally had that same exact conversation of how many data science projects are there across this 50,000 person organization. And I have to go around and talk to people by hand and write it down. And we've actually started to put in place some things. We're referring to and building on the idea from Netflix of having the paved paths, which they articulated very nicely, of like providing a way for people to do things and providing that structure, but also providing the flexibility of off ramps and on ramps for experimentation and trying new things. But one of the parts that we've built into that paved path idea is having an intake form and actually keeping track of projects and where they are in the life cycle. And we actually represent that out to our leadership on a dashboard that's updated once a month. So every team just has to go through and spend 10 minutes a month updating the status of their different projects. And it's actually at least gives us that visibility to be able to answer those kind of questions. And we actually were able to use it in an update to the president of our organization just last week, where we were able to just go through the column of which things are in production, what value can we articulate for each of those, and summarize that together in one slide for an executive readout. And it worked quite well. It's the first time we've actually been able to put it into practice. So we're really optimistic about trying to come along away from this Wild West into a kind of more organized state.
It definitely takes a lot of planning, a lot of dedicated thought, and I imagine a lot of collaboration between your peers too to make it.
Oh, for sure. Lots of organizational collaboration and getting people to buy into the value that having, we're always very Dell has a lot of autonomy internally, and so anything that sniffs like bureaucracy, everybody gets like very wary of. But because enough of us had been through this process ourselves, we were able to talk to all the various data science managers and agree that this was going to be something of value for us. And so we put it into place, and it's already showing good effects. So
great, fantastic. Thanks for sharing that, Randy.
yep.
In summary of this opening section here, I think it's important to take away several key mindsets that fit just exactly with what Randy was saying there with her experience and with this whole treating data science as an organizational capability. So as we go through these, check yourself and see if you hold these to be true and if you are championing these in your organizations. The first is that reusable knowledge is more important and of more value than producing an answer. Producing an answer, we are in single player mode. We are solving a point problem. We are looking to finish this project and not thinking about how can we improve our data science organizational capability by building something that's reusable. The second is focusing as a leader, especially more on the speed of iteration than on big breakthroughs, but not only as a leader, as an organization too, helping the organization, helping executives think in this direction, helping your leader peers think in this direction. The third is tool agility being more important than any one particular tool. Domino is a technology company, and we will be the first to say that technology is not the panacea solution for making data science an organizational capability at a company. Tool agility is important, but these other principles hold true as well, such as in this next one, process and culture. And that's a lot of what we're going to be talking about today, is the process and the people side of data science. All right, so let's go over what we are going to cover for the rest of today. We're going to start by talking about process. How do we deliver measurable, reliable, scalable outcomes? Next, we're going to jump into people. How do we attract, hire, onboard, retain, and organize world-class talent? And finally, we'll end very briefly with a few thoughts on technology that might help us be successful. So let's jump in with process. Really, when you think about process, it's just three simple things. And there's obviously a lot of details that dive into each of these three, but it's deciding what we do, and then actually doing those projects, and then wrapping up those projects. So if we can get better at these three stages of the process, this will be key to helping us in our data science flywheel. And this would be a great, as we're going through these slides here, that first part was kind of setting the stage, motivation. This is the nuts and bolts. This is the meat of the presentation. If you have questions, please put them in the chat, and we will be happy to answer them in the flow of conversation, because we're going to jump through a lot of different points and best practices and tips. So we don't want to lose the flow of your thoughts and your questions. Okay, so first let's start with engaging the business and deciding what to do. So how many of you have seen a project start in this way? We have some data. We've talked to IT. We have very interesting data on customers or product or whatever it might be. And from that data, we have great talent that starts to do some analysis. That leads to a product idea. And then once that product idea is built, we say, okay, this is a great product. What KPI can we attach to this so that we can prove to the business the value of our product? The pitfall here is you're wide open to scope creep. Because you're starting with the data, you're not engaging stakeholders from the beginning. And because your measure of success is the last thing you do, it's not crisp, and it's really just like a model can be susceptible to leakage and getting an incorrect measure of accuracy. Doing a project in this order has a similar analogy to it. Instead, what we want to do is start with the business. Start with the problem. Don't start development work until we have a relevant KPI. Then we build those project requirements, and then we do our analysis, and we go and gather our data that will support that analysis, the project requirements, the KPIs, and the problem. You get greater focus of work and lower risk in this case. The key things to keep in mind here are educating stakeholders on what's possible. Something that I'm sure many of you have faced is avoiding that perception of magic, and how do we communicate with other leaders what data science actually does and what data science actually is. Also allowing stakeholders to submit ideas for data science projects, and then communicating regularly with stakeholders what the project backlog is. And I know, Randy, you have some thoughts on that. I think there's a slide coming up. Yeah, I think it's this one where when you and I were talking about this presentation, you had some
Yeah.
interesting thoughts on your backlog process at Dell.
Yeah, absolutely. I love that slide before the bit about starting from the data. I always refer to that as data prospecting. You're telling your data scientist, there's gold in them thar hills, go find it. And it sets the data scientists up so many times for like, there's all of these expectations that you're going to find magic in that data that you have piles of. And then when the data scientists don't find it, or it can't uh, answer the questions that the business has prioritized as top of mind or whatever, then they're like, well, data scientists, why aren't you trying hard enough, right? Like there's just like a mismatch of expectations versus reality in that model that doesn't set anybody up to turn out happy. So one of the things that I love about this project prioritization is this idea of value versus effort. And so one of the things that we've recently implemented on my team is we have a variety of different stakeholders across the organization that were all coming to the team independently, and there was no common intake methodology, but then also being subject to prioritization by value without effort being considered whatsoever.
Mm.
And so, especially in organizations like Dell, which came out of, that's the part of Dell that I'm in is like the back office, like business piece, which has a lot of folks that are really smart and know Dell's processes very well and understand the business problems really well, but don't necessarily have as much exposure to using the data to answer those questions. And so, being able to articulate that you have to fold in that effort, like you can have something that is the highest priority, most important thing for the business to solve, but in the absence of data that allows you to solve that problem, like there's not anything the data scientist can do. And so having that conversation about technical feasibility is really important. And so we've put together now a prioritization uh, structure so that we have several different factors that we weigh anytime we bring in a new project, including the strategic value of it, the ties to the stakeholders, but also the data availability, the technical feasibility in terms of like whether that's a solved problem or whether it would be like completely greenfield, and using that to rank where our opportunities are and be able to use that then as having all of the stakeholders as part of that conversation and ranking exercise means that when their thing falls below all these other things, they recognize why those other ones are at the top of the list so that they're actually understanding about what it is that made it so that we chose not to work on that one right now, but also they know where it is in line. So as soon as we've marked some of these other things off, we'll get to that. And so and in the meantime, that also is a really good opportunity to identify gaps. If you have data gaps or process gaps that are going to make the feasibility of your project hard, if that falls below the line, then they have the opportunity to take some of that time to go fix some of those upstream processes that will make it so that a few months later, when the data scientists free up, they can come back to this problem and actually see more success with it, and everybody wins.
Yeah. Um, to add another data point to what you're saying, this was not when I was a leader, but I was a practitioner working for Intel in a manufacturing process, doing statistical and data science work and research. And they had a process somewhat similar to what you're describing at Dell. So I think this is a second data point of a very well-defined process helping with project prioritization. This process was called a review board of sorts. And engineers would have to go and present their proposal for changes to the process of building silicon based chips. And it was a very detailed review process, and analysis and data was a big part of it. It was basically like a project proposal pitch to the technical and executive powers that be. And that really helped everyone understand how do we prioritize. It was a common framework. Data needed to be there to back up your decision before you even started working. So two data points here for you guys in favor of some type of formal process to review project prioritization. And of course, Dell and Intel are two more sophisticated, larger companies. So you might grow up into that, but working and knowing that that is the North Star, I think can help. There's a great question about how to, if you don't have a good KPI, how do you minimize cycle time? How do you keep scope creep from going, especially if you don't know when you're going to be done? We have some really good slides on that coming up, and so I'll keep that one in mind, and we'll see if we can answer that one here in the
I
next.
did want to follow up on one other comment in the chat, though. Tanya mentioned she likes to tell stakeholders that it's a forest and I need them to help me by being a compass. I really love that analogy. I've used a similar one of being told to look for a needle in a haystack, and I'm in a field full of haystacks, and I tell my product stakeholders, like, I need you to tell me which haystack to look at first. And so yeah, totally 100% with the analogy there.
Yeah, great. And thank you, David, too, for sharing a blog post there as well.
Yep.
So prioritization pitfalls, where do we fall short when we are prioritizing? Obviously, we want to avoid never-ending science projects. We want to be very focused on the business. And part of this ties into when you hire. You want to hire people that are curious and lifelong learners, but are also really enjoy building things that work. You want to hire people that enjoy seeing their work in the hands of a customer and having that customer extract value out of it versus someone that's just so excited about research for the sake of research. You want to make sure that we don't overlook linkages between model insight and business action. It's all about that business action, and everything we do, everything we communicate has to be focused on that instead of, like the next bullet point, what's easy or what's clever. In the cost, this starts to get a little bit to it was Ruben's question. In our cost estimates, we need to consider integration, maintenance, retraining. There's a lot more to this life cycle, and scope creep is very easy to happen. So we want to make sure we capture those things in your cost estimates. Project kickoff. A question I might ask all of you, and maybe a few of you can reply in the chat. Where do most projects fail? What's the cause of failure in most data science projects? Maybe we'll get a few people to chime in on the chat, and I'll share a few thoughts. Bad use cases, yeah. And that the blame for the bad use case can be on both the data science side and on the business side. But if business sends you a bad use case, I would say the onus is on data science teams, analytical teams, to educate better and to make sure we don't start those bad projects. Not plugged into the decision process, not enough time and requirements, taking too long to get to production, lack of success metrics, no clear defined scope, lack of clear problem definition, production.
I think there's a really great point embedded in there that no one admits to failure. That can often be, I mean, talking about bad use cases being brought by the business, sometimes, yes, the data science team should be on the hook for educating better, but also sometimes that's not going to fly. And so then what do you do?
Yeah. And that's where that review process can help you say no when you don't want to say no. You burn political capital if you say no to a project sometimes. And if there's a third-party review process, that can help a little bit. You keep those relationships, but you still say no to the bad projects. Great comments on there. Keep them coming. Often, I think this is a good summary of a lot of what you're saying. We don't fail because of the math. We fail because we don't anticipate how the math will be used. So this is not understanding what the requirements are for the delivery model. So in production, in the hands of the users, is it going to integrate well with their workflows? Are they going to have to go to a new screen? And there's just no way they're ever going to a new screen. They're stuck on this one screen. And if you don't integrate with that screen, the project's going to be dead no matter how great your model is. So project kickoff is really vital. The amount of time and money and investment you spend here is going to pay great dividends. And standard project management principles apply to data science projects just like they do to engineering projects. So let's talk a little bit about including stakeholders. Several people mentioned that in their comments. It's important to define who the responsible parties are from various groups. So again, this depends on your organization. It'll vary on size and sophistication of organizations, but you have the data science group and you have the business. Those are probably at a minimum, you have to have those. Often you're going to need a DevOps member, application development, and then you start to get into risk and compliance and mitigation of those other risks in certain industries and for certain companies. And we need to treat these teams as cross-functional teams. Talking with an executive from, I believe it was Salesforce, if my memory is correct, but it could be a different team, a different company. They, at the beginning of a data science project, they lock this collaborative team together in a room for 2 to 3 hours and say, you're not allowed to come out until you agree on this project pre-flight checklist, for example. And just really focusing on the collaborative part of data science projects. It's never just starts with data scientists on their own. It's always collaborative. And I thought that was the best practice that I heard from them. Common pitfalls, we need to put ourselves in the seats of the user, and how are they going to use this? Is it going to help their world? We can't just throw stuff over the fence to IT without any context.
Converse is, if you're organizationally set up to have to throw things over the fence, you need to proactively make that collaboration and bridge in place, because they may not be expecting that they need it.
What have you seen, Randy, that has helped to build that bridge?
Lots of talking. I mean, I would say we're still actively building it at Dell, and it depends on which group we're implementing with in terms of where different things get consumed. But yeah, I think there was, before the data scientists as a practice really got started up, there was a lot more of a sense of like, you just throw it over the fence and then it's mine and I take it and go. And we're like, no, like you like still need to be talking to us. We got to be like, we need to know how you're going to use it and where it's going to get implemented. And you need to make sure you're logging for these things, because we're going to need that information later. And there was a mismatch of expectations compared to like the usual. They would get stuff from just like product managers that hadn't necessarily done as much of the technical deep dive on it already. And so we're like, no, we have very specific requirements, actually. Like, we've thought through this. And they're, by bridging it, by talking lots.
Part of that goes back to that model myth of not understanding the nature of data science, right?
Well, right.
It's probabilistic. Data science projects are going to fail on a regular basis because they're probabilistic, and it's more like research in a life science lab than it is developers sitting down and just waterfall coding projects. And I think often for IT, it takes a lot of talking, as you said, to help them realize that. And for other organizations too. So on the technology side, consider opportunities to accelerate research. So if we're thinking about data science as an organizational capability, when we're looking at technology, what we should be looking for are technology components that help meet that goal. Collaborative technology components that are going to help build the bridge between IT and data science so that we get things into production quicker. Things that can build a knowledge repository for project reuse and asset reuse, and identify those dependencies early. Common pitfalls that we've seen companies get in a little bit of trouble is if they try to go with a one size fits all. They try to say, all right, we're going to standardize on Python only or on R only. And that might work sometimes for some companies, or we're going to use this drag and drop tool. But often you need to give your data scientists the flexibility to work in a variety of technologies. And as this world that we live in, this industry that we live in changes so rapidly, and new technologies and new best practices come out, you want to be positioned with your technology investment to be able to take advantage of that. Okay, on data availability, there was a comment I saw on Why Projects Fail about data. So you want to obviously pave the road before you buy the Ferrari, and you're going to need to invest a lot of time up front, as you all know, on your data stack. As you do that, though, you don't have to wait for that data stack to be built before you can have successful projects. You might just need to modify your projects and have them build them with a more refined scope, and have them be smaller, quick hitting projects rather than hitting the home run until you have that data road built out. So don't go for an all or nothing mentality. Iterate to excellence here. Randy, any thoughts on data availability?
Yeah, I mean, one of the things I love the comment, Tanya and Daniel in the chat there were talking about the collaboration with IT and stuff. I mean, we have still data availability in an organization as large as Dell has been a big pitfall for us. And sometimes we can get access to the data and move a project forward very quickly, and sometimes it's in a part of the organization that, I mean, it's a very large organization. Sometimes like getting those pieces to line up can take months, and it's definitely one of the things actually with our project dashboard that we're attempting to do is by tracking when projects initiate and how they progress through the life cycle. We've actually we gave data ingestion its whole own phase of the process of like how long from concept to when you can start working, basically. And we're trying to use that as a way to start to measure how long that stuff takes and be able to see, as we bring in and hire more data engineers and as we invest in all this money in our infrastructure, like, is it reducing the time to get started? And so we've spent a lot of time and effort trying to address some of those problems. And then we're kind of now backing into KPIs that we can measure to actually say whether it's working or not. But the thing about the trust and commitment from both sides is huge. And I again, like, solved with more talking, but it's one of those things that like continues to be a big deal. And I think that a lot of data scientists don't anticipate when they come into the field how much talking is part of the job. And so it's a good thing to kind of weave into their expectations as well, because I think they expect, from Kaggle and boot camps and things like that, for things to just be ready to go in a way that in the industry they're just often not, and you have to be a coordinator for part of that to get your project to a successful place.
Mhm. I feel like in building that bridge between IT and data science and bringing the data along with it, it's also a bridge to the data. um, IT it's often the case that IT wants to be involved in data science projects. They want to have that on their resume. It's interesting, it's new, it has neat technology components to it. So I think that as has been mentioned a little bit in the chat, there is some fear on both sides from data scientists and IT, fear of the unknown, fear of not being accepted, fear of looking dumb. And so as leaders, this is where I think, can really make a big impact, is starting to figure out how to build those bridges, whether that's sessions, lunch sessions together, or whether it's, lunch and learn from each other, whatever it might be, whatever works for your organization. But as a leader, thinking about that and being proactive and intentional about building those relationships between the data stewards and the analytical stewards, I think is really important.
Yeah, actually, one of the things we did with our team in the last year is we found basically all of the major stakeholders we regularly engage with, the groups. So there was a data engineering team, there was a front end engineering team, there were two different sets of product owners and product managers, and then there were also, and Dell, like, they're the actual hardware engineer people who build computers that we also had to interface with. And one of the things that we put in place was uh, inter integrating with each of those teams in such a way that we got one point of contact and liaison to be like our bridge person to that education point of view. Again, like, it's too much to educate an entire organization on the backs of a handful of data scientists, right? Like, that's just too big of a job, and they're supposed to be delivering value. They don't have time to spend all of their time just educating people. But having, like, I can get this one person to understand the language I'm using, understand the way the process works. And so, like, one person per team, and then they've been able to take that back to their orgs and facilitate for us. And that was a really impactful thing for us in the recent history. And part of there was a good question about agile in data science. That's one of the things that we've kind of folded in. I call the bridge people liaisons, is what we've been referring to them as, but we fold them into our agile process by doing our biweekly sprint retrospectives and demo sessions. We make sure that those stakeholders are involved in those and being kept up to date on what's going on, so that way they can speak to the here and now all the time, and they're not just waiting for us to engage them whenever we need their team.
Yeah, liaisons, ambassadors. There definitely needs to be a bridge between business and data science, and sometimes, as we're talking about here, between IT and data science. On the agile front, I would agree that agile principles can help and have a place in the data science lifecycle. But I do think that we need to be careful about just using agile tools carte blanche. the data science lifecycle is a little bit different. And so it just takes some thought about how do we integrate the best of Agile into the data science world. Um, as one point example, with Domino, with our platform, we do a lot of project management in our platform, along with the DevOps, which is kind of our bread and butter. But we just integrated with Jira, so we have a brand new integration with Jira to help through it, like a task management solution. So there's definitely a lot to be had from existing tools and solutions and methodologies like Agile and tools like Jira that can fit in, but it needs to be, in my opinion, modified a bit. There was a quick question in there about scope and an MVP, and I think it was regard to my comment about enabling R and Python versus just one or the other. I think that might have been where the comment came from, the question came from. It depends on your organization, but I've found even for small shops that they have trouble hiring the right talent if they limit their data scientists to a certain way of working. And we'll get into that more in the people aspect, but data scientists can be a little bit finicky sometimes. And
I resent that comment.
You resent it? I represent it.
Fair.
We like to work with the tools we like, and we don't want to feel like we're caged in.
There's a lot of good comments in the chat about like those bridge people and that idea. One question in particular is like, what kind of role is that? And one of the things I would say is that I don't consider it to be a role in and of itself. It's that team already does whatever they do, but having a person who does that thing and also speaks the data science language is what's important about that. So I would say that it's, kind of an add-on or flexible, it's a translator role, ambassadors, like all of these are good descriptors for what that means. And I think it's just a matter of them in the midst of doing their own job, also understanding data science and being able to figure out how to start to pull those pieces together. So we're all working on building the collaboration, not just like the data scientists insisting that everybody needs to collaborate with them, but then everybody else is like, what are you talking about? I don't, so I think that's a big key for that.
There's also a trend that I'm seeing as I work with a wide variety of companies. I'm seeing a strong trend towards centralization in ownership and in executive thought, and even sometimes in the data science teams. I'm getting ahead of myself. That's going to be covered in the people section, but I think that ties into this as things centralize a little bit more as your organizations grow. These ambassador roles can have a natural place to have their discussions. There's a natural forum for discussions in some type of central, either official organization or a matrixed organization or virtual organization, whatever it might be. Okay, this is a great discussion. I'm glad we took the time to do it. I'm going to move on. I didn't want to cut it off early because I'm kind of the opinion if there's a lot of discussion happening, we let it roll because that's what people need. And my goal is just for this to be useful for everybody, not to cover all the material. We are trending a little bit behind, but that's okay. Like I said, we're having a good discussion here. So the last point on data, use what's available before you go and purchase data. This only applies to some industries, customer data, financial data. They do a lot of purchasing. So use what's available, and you might even want to create synthetic data with realistic characteristics to test out your theories and your models and your end delivery before you go out and spend the money to buy that data. Okay, this is a big one, in my opinion. This is a soapbox I get on a lot because I've mentioned this phrase once before, but I'll mention it again. I personally hold that the scientific method is very important, and that data scientists we should think of ourselves as guardians of the scientific method. And we should think of our teams as more like a life sciences research team that's, for example, trying to find a vaccine in the news lately. And as we're researching that vaccine, failures are just as important as successes, or they have a lot of importance. Let me at least say that. And we don't throw away those failures, we learn from them. Everything we do is research. And as we research, we're gaining knowledge, sometimes about how not to do things, sometimes about how to do things. And we need to have a system, a way to keep that knowledge and to be able to share it with others. So that's where prior art review comes in. We want to have a way to capture what's the state of the art for our organization, and also to be able to tap into what is externally out there, because there's so much out there. Uh, Fortunately for us in our industry, there's so much we can get from the internet right now, about even down to how to do different code projects, but technology, there's so many different aspects of our work we can find externally nowadays. So we definitely need to avoid the not invented here culture. We need to be open to that. I know, Randy, you like to say data scientists need to be lifelong learners. I think this plays in here to this joy of creating knowledge, and having that, and seeing your coworkers use something that you built, even if it was a failed project, in the success of their project. Another large company that I worked for, an executive there told me that almost all of their breakthrough projects came off of failed earlier projects, that people went through the backlog of earlier failed projects, saw something that applied to a new problem that they were thinking about, gave them an insight, and they went off and built this breakthrough home run that really made a big difference. But if they didn't have a way to track those past failed projects, they wouldn't have had that.
Well, and I think this comes back to the intake and checklist conversation from before too, because one of the things that we've spent a lot of time on is building a community of our data scientists. And so they tend to have a good view of like what's happening now, but they don't necessarily know what everybody worked on 6 months ago, 2 years ago, whatever. And so like some of that stuff like fades back, and baking in time for them to actually like step back. Now that you know what the problem space is, go dig around a little bit. Like nobody's going to care if your deliverable is like 3 days later because somebody went and read through some Confluence pages, right? Like that's not, usually things aren't at that scale of urgency. And so just enforcing for the data scientists, because they get it, you get a problem, you get excited, you start to want to work on it right away, but forcing yourself to take that step back is really important.
Yep, definitely. It's a must. It's a must do. Okay, I'm going to maybe move through these last 4-ish slides a little bit quicker. Unless you have questions, throw them in the chat, and then we're happy to pause and talk about each of these. So the model delivery plan, we've mentioned this a couple of times. Just make sure you have one before the project starts. On a piece of paper, even draw up how this is going to integrate with the end users. What are the end users going to touch? What are they going to do to integrate with the insights and to use the insights that come out of your model project? It's a simple thing to do, but it really needs to be done early on before the project starts, because it will affect even things like how interpretable does your model need to be. And that might limit the algorithms that you can go after. Maybe you can't use a deep net because it's a black box, and people need to understand a little bit about how this model works. So it will affect a lot of things. Make sure you have that delivery plan up front. Success measures. How will we know if this works? Can we frame this in a business KPI? Do we need to plan for holdout groups for A/B testing? Make sure this is part of your pre-flight checklist. What are we doing? What are we going to do for success measures? One company I worked with, I thought it was really cool, and I've heard it once since. They turned their data science, let me say it this way, their data science team was the only team in their organization besides sales with a revenue target. I thought that was really cool. Their organization and their industry was selling product, and so they were able to, with A/B testing, quantify how much additional product they could sell with targeted campaigns and things like that. So it worked for them, but that was really cool to have a revenue target for the data science team. Talk about getting the attention of executives and of leadership, and getting funding for more data scientists and whatever it is you need. That really works. So whatever is going to work for your industry, but make sure this is in mind. Risk mitigation. Considering the consequences of type 1 and type 2 errors. Often this is something that will require a lot of education, because the concept of these projects being not only probabilistic in their development, where they might not succeed, and that you might spend 2 months, and then at the end of the day, you know what? It's just, this isn't going to work for whatever reasons. We don't have the data, the models aren't strong enough. But even if a model gets into production, it's going to make mistakes. And educating people and stakeholders about that and being able to quantify that is not an easy thing to do, and does take some time and thought. Randy, I believe you had some stories related to this one, if I'm not mistaken.
Yeah, I mean, I think one of the things that was really impactful for me was reading Kathy O'Neill's book, Weapons of Math Destruction, and hearing about, always thinking about the implications of anything that you do. And I think one of the ways that it really struck me in a particular example that this was when I was an individual contributor. We were asked to do a project to help identify, right? I'm in the services part of Dell, which deals with tech support and repairs and everything that happens to a machine after it gets into the customer's hands. And so one of the things we were asked to do was figure out if there was a way to identify whenever someone from a small business calls in to get a repair done, they don't actually call the straight up tech support agents like you or I would do. They have they can get pre-certified to order their own parts and things like that, because most of the time they have their own IT department who troubleshoots their issues for them. And so we of course have fraud detection on that process to make sure that the right parts are being ordered and that everybody's consuming those in good faith and everything. And one of the things that we were talking about was if we could um, do a more automated way of performing that audit process. And someone had suggested doing that by customer segmentation, saying these different kinds of customers are high, medium, low risk. And I had just read Kathy O'Neill's Weapons of Math Destruction and was thinking about constantly how could anything I make be used for unintentional outcomes. And one of the things that occurred to me is, if you're a relatively small business and you get classified in that higher risk category because your IT person, maybe made some transactions that looked fraudulent at the time, even if they maybe weren't, but you can get classified in the system. And then, maybe that person doesn't even work at your company anymore, but you're victim to small number statistics because yours has been classified, and who knows how often that will refresh. And so then you now have this administrative burden that isn't really due to anybody at your company's fault, right? Whereas if we did that kind of audit process at a transactional level instead of at a company level, then it neutralizes the possibility of that being used in a way that puts certain customers at a disadvantage or at an advantage. So we were thinking really hard through the implications of large customers with lots of IT people submitting through the system would be less uh, they would be more likely to have bad actors slip through than if you're a smaller business. And so really thinking through the implications of those, any model you make, and whether or not, even if it's not going to be some I think a lot of the ethics in data science is about gender bias or racial bias and things like that, but there's also just ways that you can cause outcomes that you didn't mean to have happen, and aren't maybe good for your customers or your employees or whatever. And so it's always good to be thinking through uh, the possible risk any solution could bring up.
Yeah. That small sample bias is one that is not going to come across a standard filter. It's going to take someone with a bit of
Right.
experience to be able to
Right.
catch that. Yeah,
Yep.
that's a great example. Something beyond the usual biases that we screen for. So the last slide in this section on process, wrapping up projects. So let's store positive and negative results. Let's be able to synthesize our intermediate results, highlight those in some way. Code, data, and environment are all needed for reproducible work. You can't just have code and data. You need to also have the versions of the packages and the software environment, the operating system. All of that needs to be captured in order to have full reproducibility. That's one thing that Domino's platform really seeks to try to help with, is capturing through Docker and Kubernetes the states of the world at those different inflection points in your process. An executive at a large company I talked to said that he does team stand-ups, and in his team stand-ups, he has reviews of intermediate results in their team stand-ups, and shares those with has people share those with their peers as a way to help enforce this best practice of capturing results and documenting things along the way. He even went so far as in their performance reviews, how much do you contribute back to the organizational knowledge base? That's part of their performance reviews. So another idea there. Okay, at this point in our workshop, typically we would stop for about 30 minutes and or maybe 20 minutes, and have each of you break out into like groups of 5 where you would talk together about a pre-flight checklist that you have done in the past. Um, we do that because it's really good for everyone to learn from each other, and that we've heard that that's one of the best outcomes that people have from this workshop. But in our setting here, we are not able to do that. So we can't get you, and we didn't want to do breakout rooms. That would just be too hard. So plus, I don't think you can do it on a webinar, and we're on a Zoom webinar. So some technology challenges with that. The good thing is, though, I think that in this chat, we're hearing from a lot of you already, which I really appreciate all of you chiming in there. Because again, you hear from me and Randy, you have the slides, you have some concepts, but often it's really good to hear from your peers and to hear some different points of view. So a little preamble there, probably too long, but please take a minute, and you might have gotten this in an email when you registered for the workshop, but it's here in front of you now. Take a minute and think about these questions. And if you could, as you're thinking about your answer, if a few of you don't mind typing your answers into the chat, and then we'll see if we can have a little bit of a conversation about this. So the pre-flight checklist, what's the business case? What's the desired outcome of the project? You're supposed to take an example of a project you've done recently and go through this and then kind of assess yourself. How did you do? What are linkages from your project to impacting the ultimate business metric? What was the ROI? Did you estimate ROI and cost? And then on delivery, did you figure out who will consume and what form factor it will take? What dependencies and resources will it take to deliver it, for example, with IT? What are other possible delivery mechanisms, maybe lighter weight, easier to test at first? And was user training used? And then on success measures, how will you know if it was working or as expected? Did you get feedback? And what other roles did you involve? What considerations did you have from technology, data? Did you capture prior art? And how about risk? So think about a project that you've done recently. And if you don't mind, maybe I'll zoom out a little bit on this. See if you can answer a few of these questions in the chat, or maybe share some of your war stories. This is really what this is meant to be, a war story sharing time. And maybe we'll comment on a few of those. Or we can answer questions too. That's a question on that question on lifelong learning and age is an interesting one.
Yeah, I was thinking about that too.
Yeah, I'd have to think. To be honest, most of the data scientists I work with are younger than me, and I'm not too old. But
Oh, it's so interesting because I actually, several of the people that I value the most that I work with in the data science space are, 55 or 60. And I think that I would not be as mature of a data scientist if I had not gotten to have the experience of working with them. And that whole, some of this stuff that we're talking about like having a nose for what's going to be a good project and being able to say no to things that are not going to pan out and not be valuable. And a lot of that I've learned from people who have been around a lot longer than I have. And then I think though that's, I don't necessarily know that that's directly correlated with age. I think there are people who are just driven by a burning need to continue learning new things their whole life. And those are the people that you need in your data science sphere. And if you have somebody who, I get that, I mean, as a manager now for the last year, as opposed to being a practitioner for the prior several years, like I keep up with things via, reading Twitter on Saturday mornings and looking at blog posts in the evening and things like that. But I don't necessarily get to bake it into my day job as much as I used to. So I think, yeah, I think having diverse teams and people who are going to seek out those opportunities to learn is really important. But as a manager, that's one of the reasons why I find it really important to give opportunities for my team to take time to learn too. So actually, we got, a couple of tickets by presenting here, and I made sure to share with my team because I want to make sure that they're getting opportunities to flesh out their curiosity and learn new things constantly too.
definitely. Yeah, I think everyone these days knows the advantage of a diverse team, and the definition of diversity being across many different cohorts or form factors.
I do think the diversity in age gets swept under the rug a lot, though.
Yeah.
That's not one that we often talk about, but it's also important.
Yeah. There's obviously gender, culture are two big ones that bring a lot of diversity of thought. Age is one I agree that gets swept under the rug. Okay, great. Some good comments on there. Angie talked about wanting to use Tableau, but then this data was too large, made that impossible. Had to shift for her from delivery. Okay, great thoughts on all this. Keep it coming. I think for the sake of time, and since we're already having a lot of really good discussion going on here, I'm going to keep going with the slides and move on to the people section.
Since we're talking about people.
We've worked people into a lot of this already, haven't we?
We really have.
Yeah. It would have been good for me to show this slide while we were talking. This is a summary of that little handout that I was showing here. Okay, people. So why do we focus on people? I have given a subset of this workshop to an analytical MBA course before, and I only had time to give half of it, so I gave the people half. And managing people in an analytical world is definitely a little bit different than just your standard management practices. There are some nuances to consider, so we're going to point out some of those nuances. We'll share some of our ideas. Please keep your ideas coming on the chat as well. So in the data science world, the talent gap is often cited as a big obstacle. You have some software companies that their entire pitch is around closing this talent gap and making it easy to help people that don't have that background be more productive in data science. So it's definitely there. There's businesses that are just trying to fill that talent gap. The typical tenure for a data scientist based on research is less than 2 years, and it takes 3 months to ramp. So you don't have a lot of time unless you can do better than average at retaining your data scientists. So we're going to talk a little bit about that. Also, there are many roles to fill. We've talked about an ambassador and liaison, maybe not being a role, but a part of a role that someone can take on. We'll talk about a few others here as well. Also, as leaders, it's very easy for us to get overwhelmed by resumes because data science is a little bit hot and there's a lot of marketing around it, and AI is a buzzword that's just gone crazy. We can get a lot of resumes and they're not always going to be meeting what we're looking for. So here's the framework we're going to walk through: how to attract talent, how to assess talent, how to train talent, how to retain talent, and then how to organize that talent. So start with attracting the talent. One best practice that I found is to have a differentiated offering and strategy. So think about what is unique about your company. You're going to be competing always. Every single time you're hiring somebody, you're going to be competing with other companies to hire that talent. Maybe you are not in San Francisco or New York, and that is something that is a feather in your cap. We're in Sacramento, we're in Austin, we're in Raleigh, North Carolina, we're in wherever it is, and that might be appealing to some people, and they might want to go that route. So find out what's different, what's special about you. Maybe it's your culture, maybe it's your mission. Whatever it is, really don't underestimate selling to the heart as well as to the mind. And when you're selling to the mind, be sure to advertise the projects. When I first got my master's in applied stats, I had a job offer at a company that I really liked, and it looked exciting, and I thought it would be really cool. And I went there for an interview, and they would not tell me about the projects. And it was part of it is because they're trying to, like, oh, it's IP, we can't tell you about it. And I ended up going with a different company. I couldn't visualize what I was going to be doing there. And so there was too much risk for me in being able to make that decision. So however you can, try to let people know what they're going to be doing and what they're going to be working on. Not only will it benefit them in their decision making, but you don't want to hire somebody that's going to be leaving earlier than you would want because they're not a good fit for the projects or they don't enjoy it. This gets to my comment earlier about using a variety of tools. Is I've found and I've heard from leaders at small teams that being able to offer Python, R, SAS, MATLAB, whatever the variety of tools, and on a variety of platforms and hardware and software and DevOps help, DevOps training, to be able to offer all these things can really be attractive to data scientists because they want to build their resume, they want to continue to improve, and the industry moves really fast. Don't write unrealistic job descriptions, and don't seek PhDs when you need hackers or vice versa. So be realistic about it. Don't shoot for the moon when you don't need to. How do we assess folks? So it's pretty funny, and I would be curious to hear how many of you fall into this trap, but you're analytical in every aspect of your life except when you assess talent for hiring for these roles. We're too often not systematic. We're not analytical about it. And so we need a way to not only to protect against our own personal biases, but we need to be interviewing in the same way. We need to be asking the same questions. We need to be giving people the same chance to get hired, and to look for ethics and bias in our interview processes. And being analytical is a great way to make that happen. Of course, you want to look for the emotional quotient, not just intellectual. So looking for those soft skills, as Randy said several times, a lot of their job is going to be talking. And as I've mentioned, the desire to build a product that is put into production in someone's hands is really, I think, a really important skill or characteristic to look for. So include that into your hiring process and figure out a way to assess for that. And then while you're assessing, sell. Always be selling, always be closing, always sell your company. There's a lot you can do as a salesperson, as a leader, to attract and assess this good talent. Don't over rely on text screens would be the common pitfall. Of course, you can have the text screens, and you probably should, but don't just solely rely on those.
We actually, our text screen involves some of the, like, how would you communicate this to stakeholders? How would you answer these questions in a way, so folding some of that EQ and stuff into the text screen itself has been really, really immensely valuable for us.
Yeah, that reminds me, I heard a data science leader once say that this was a little bit mean, I thought, but it worked for them. In their, when they have the candidates do a project on their own, come back and present to a room of evaluators, they have one person play a really antagonistic confrontational role. Like they're playing a role and they're challenging them, and they're kind of calling them out on things that might not be right with their project, or that are a false accusation. They want to see how the person responds. Do they respond with empathy? Do they or do they get mad? It's a way to kind of test on EQ. So I've never done that, but maybe I don't know. Maybe it's a good idea.
It's an interesting idea, certainly.
A little mean, but okay. With training, I think this is huge, right? And I'm sure many of you are investing in training your talent. Not only does it increase their ability to be productive, but it keeps us happy. It keeps data scientists happy. We like to learn. We like to go to conferences. We need to do that. We need to be around others. We need to cross-pollinate ideas. And we also need soft skills training as well, especially for data scientists that want to improve their brand. If they want to maybe someday be in a leadership position, they're going to really appreciate you and that organization, that company, providing those skills. I know, Randy, for you, you've been a big champion, and you had to kind of fight through some red tape and some barriers and some preconceived notions about allowing this external training to happen with your teams at Dell.
Yeah, I mean, Dell has like training budget that they give to people for continuing education and stuff like that. But the idea of like a lot of our data scientists, at least, especially in our initial phase of hiring, were, people coming out of academia who had like, science or CS backgrounds and things like that, that were used to presenting their work at academic conferences and using that as an opportunity to grow their network and come up with new ideas. And that kind of fruition of sharing and learning and cross-pollination, like you articulated, if you hire data scientists for that lifelong learner mentality, then they're going to be the kind of people who genuinely are going to want to be doing that stuff. And so many of the folks in the analytics teams that we had gotten hired onto were just unfamiliar with that as a thing that typically needed to happen. And I had to have a lot of conversations with those people's different managers of like, you need to budget for conference funding. Like that's a thing that data scientists need to have, right? And so that's a constant refrain is like giving us opportunities. We actually just recently did a kind of mid-year retrospective with the data science community. And one of the things that they pointed out that out of the stop, start, continue, almost all of the continues had to do with the sharing of ideas and the collaboration that we already bring into the projects we work on. And most of the requests for things to start were more opportunities for professional development, more hackathons, more learning, more conferences, like all of that sort of stuff. So yeah, we actually started sponsoring Data Science Salon. The last 2 years, we've sponsored that as a conference in particular so that our data scientists could go to it. By hosting it, we actually got the opportunity to make sure that they had that professional development opportunity as well.
Yeah. Yeah, it's super, super important. I think it's a must-have to keep talent happy and help with retention. Setting expectations on the time allocated up front. This is from a friend of Domino, Max Schron at Warby Parker. You probably maybe have seen similar graphics to this. So data scientists who are new to the profession coming out of school think, hey, I'm going to be spending all my time on math and programming. And then they hear, oh, wait, there's this 80-20 thing, about 80% data prep and 20% math and programming. Okay, now I got it. And in reality, that 80-20 is shrunk down to about 40% of what you really do. And the rest of the time is listening and talking to stakeholders. And then also don't forget about monitoring your models and doing the dishes at the end of the day, making sure that what you built stays healthy and is on a good cycle for retraining and refreshing. So best practices here and setting the expectations, emphasize listening to stakeholders, compensate teams on new and existing work, not just current projects, and avoid you want to be able to screen these. You want to help your candidates screen themselves almost. You want to make sure that they understand what's going to be expected of them, what is where their time is going to be spent in your organization. You might really love them, but if you hire them and they leave within 2 years, it's just more upheaval in your organization and more time wasted. So metrics of managing data science. Excuse me. So share accountability with the business KPIs. We mentioned this earlier about a company I know, 2 of them that have their data science team has a revenue target. Really awesome, not realistic in every circumstance, but ideally you want to find that business KPI that you can tie yourself to. Focus on iteration velocity. I mentioned this a little bit earlier too, where a data science executive incorporated iteration velocity or sharing knowledge into a review cycle. There's more you can do for assessment rather than just project delivery. It's all of these organizational capabilities that we've been talking about can be integrated into some of our metrics. And have a way to systematically capture the stakeholder feedback and engagement. Some of that is in the formal processes that Randy and I talked about earlier that Randy's seen and helped implement at Dell. I added in here a blog. I know you can't link to it, but maybe you could write down some of the keywords and search it and get it. But this is a great blog written by a data science leader whose name is Kimberly Schenk. She has started out as a data scientist, I believe, in the Air Force, and has gone on to be a CEO of a company. She wrote a guest blog for us about what she does for metrics and measuring both the data scientists and the business value that they produce. So I recommend that blog. Don't forget to measure yourself as a leader and set that example, and then don't over-index on any one project. Think about the performance, the flywheel of your teams. Oh, thanks for Randy. Thanks, you got it up on the chat. Perfect. So we get back to something that we were talking a lot about earlier, and this is the many hats and the roles of data science. Um, Randy, you mentioned the liaison. Have you used any of these other roles in your work at Dell?
Well, so again, the way that we've been talking about a liaison internally is that every single one of those roles has a liaison specifically to the data science team. So there are infrastructure engineers and product managers and business stakeholders that we got each one of those teams to have a liaison to us. But yeah, I think the one of the things that is a common refrain in data science, data science is a team sport, is a famous DJ Patil quote. A lot of times you're looking for, especially smaller teams, hiring data scientists to do all of these things, and they're so different and they have such different skill sets that being able to actually have the organization be able to fill out all of these roles, as opposed to having one single person embody this whole part of the life cycle, is a lot more realistic for what you're able to achieve. And then one of the things that we've been trying to do internally is get the teams to have common definitions of like what those roles look like, and working with HR to actually build those job classes and get standardization, so that way anytime we're hiring for this, we're hiring in a consistent way. But the data product manager has been really the key one for us in the last year, because one of the things that we've faced over and over again is the like business stakeholders who, like, you really want a problem solved, but you don't necessarily have a data background, so you don't know how feasible it is. Having people who know data as part of that product manager conversation, to be able to see opportunities because they know what can be done with data, as opposed to just like, I just really, really want this business problem solved, has made a huge difference for us. And we started actively hiring for that. And it's been we've and converting internal people who were interested in data but didn't really have that experience, and kind of getting them over into the place where they're more understanding and aware of it, has been really hugely impactful for us. Because before that, basically the data scientists were having to do a ton of the ideation because the other product managers just didn't even know it was possible. So
Yeah, that's a great deep dive into how to use that data product manager role. Uh, if you have other roles that you have seen, throw it in the chat. I'd be interested to see if there's other roles that aren't on this list that you've found useful. One that I've seen, so I'm interested in explainable AI. It's kind of one of the areas of data science I'd like to study and research and read academic papers on, and see what's the latest, what's going on in that space of interpreting black box models. And as I've spoken a couple times on that topic, I've met people that are in a role that is sometimes called a subject matter expert, sometimes called a business expert. And they are similar to the data product manager, but they come at it from really a strong business background. They're not the stakeholder, but they are almost a consultant to the whole project, that knows the ins and outs of the industry and of the data as well, and can speak and help people look for bias, help people look for what's going to be needed to be successful. So I found that to be an interesting role that, especially, I saw this at a couple of insurance companies. As they were building out predictive assets for different insurance features, they had this business expert there to help be a consultant to everyone.
yeah, we use a lot of domain experts as well. The comment before talking about the liaisons, we have liaisons to the hardware engineering teams because they're the ones who actually know what is generating the data that we get, and that's been really critical for us.
Yeah, cool. And Daniel says that is a key element with his. Yeah, if you want to expand on that, Daniel, I'm sure it'd be great to hear a little bit more insight on that. Okay, wonderful. Let's move on. So one thing that I don't know if we have it ready yet at Domino. We're almost ready. We do a lot of industry research on topics that we hope and think will be beneficial to both data science practitioners and to leaders. One piece of research that we've just wrapped up on that's aimed at data science leaders is a study about centers of excellence. And we've interviewed about a dozen different data science executives and leaders and asked them about their centers of excellence. Do you have one? What made it successful? What would you do differently now if you had to start over and build one from scratch? When do you build one? When do you not build one? When do you need one? It's a really interesting space, and perhaps I'll share my email at the end of this, and I can put you on the list to get the white paper when we're finally done with it. We're really close, so it shouldn't be too long. But at a high level, this shows four main ways to organize your talent, to organize your teams. There's centralized, where the data scientists are in their own hub and they reach out to all the lines of business, and IT is separate. There's centralized under IT, so very similar, but you're more collaborative with IT, and maybe you report up to an IT leader. Then there's the federated approach, where data scientists are in each line of business, and they have closer ties to the problems, closer ties to what's going to be needed, and project idea generation is easier in the federated approach, but it's harder to collaborate in that federated model. It's harder to have a centralized repository of knowledge management. And data scientists can get lonely and isolated, and sometimes you do have a little bit more churn with data scientists in a purely federated model. And then what a lot of people kind of end up doing, sometimes you'll see this left to right as a continuum, as an evolution, is the hub and spoke, where if you're big enough, you can have data scientists in each business unit being the representative there, and you also have a centralized data science team or unit that maybe that's the center of excellence, maybe it's something else, where they are communicating with those data scientists that are out in the business units and being able to share best practices, share technology updates, share prior art. So there's definitely pros and cons to every one of these models up here. I will say, I mentioned it earlier, as an overall trend in the industry, from where I sit and the companies that I'm talking to, we are seeing a trend towards centralization of some type. It looks a little bit different in each organization, but I think this is natural as data science becomes more of a first-class entity in organizations and has a seat at the table, if you will, at the executive table. And executives really know that AI is important to them. There starts to be some type of centralization and a central data science leader that people end up reporting up to. Randi, where does your group fall on?
Yeah, I was going to mention, so we're firmly in the federated org design. The one thing I would say that is, I would dotted line those different data science groups together, because one of the things that we've done a lot of work on at Dell is to put together a data science council so that all those different teams of data scientists can still collaborate and share best practices and accelerate their own projects by learning from the work that other people have done. And so even though the data scientists are very close to the problems, and so they understand the problem space very well, we're still sharing best practices with each other and stuff. I was going to make one other comment, because I've been very interested in like centralized versus decentralized data science for a long time. And one of the executives I talked to at Dell one time, I was asking about, centralization and whether it works or not and stuff. And they were like, centralization and decentralization is just like breathing. Like, there's pros and cons both ways, and you'll shatter out into the organization because you'll be able to more specifically solve the organization's problems that way, and you'll get a lot of reap a lot of benefits from that, like that spark of creativity that comes from that. But then after it goes for a while, you'll notice like redundancies in your processes and inefficiencies and communication issues and stuff like that. And so you'll reabsorb into a centralized model because that'll build your efficiencies, but then you'll stay in that for a while and you'll become too out of touch with all of the business units and being able to solve their real problems, and so decentralize again. And so it's just like an in and an out, like it's just a constant cycle that never stops, which I've always thought was really interesting. I haven't personally seen it at Dell for data science in the 4 years that it's been operating there, but it kind of makes sense, and I could see that may be a thing where a lot of places have tried data science in these little pieces and are starting to want those operational efficiencies of less redundancy and less more communication and collaboration and less rework. And so that move to centralization that you're mentioning as an industry-wide trend just kind of reflects to me like this maturity thing of where we started and then where is the next logical step.
Yeah.
Yeah, pendulum swinging is another good analogy, someone mentioned in the chat.
Yeah. Yeah, perfect. Thanks for sharing that. Okay, let's take a second here and I'll bring up this slide this time. There is a worksheet that was sent out early. Let me go find it. I'll bring it over real quick. And then I'll go back to that slide. I'd love to hear some of your thoughts in the chat on what you've done to attract top talent. So specifically, what's your differentiated value proposition? If you don't mind sharing with everybody, this would be interesting to hear some of what you do. 3 things that make the opportunity to work at your company unique and resonate with your candidate pool. And if we were live, you could test your pitch on the group. That's always fun. And then knowing your risks. What on the flip side, what causes candidates to not choose the jobs that you offer? And then on the hiring process, what are the 3 most important attributes for your candidate? What do you look for, and what is your assessment plan for those attributes? That would be really interesting to hear. Maybe let's start with those, and then if you have this worksheet, might be interesting to hear about onboarding. What do you do in your 30, 60, 90 plan? What tribal knowledge do you communicate? And then under retention and management, what skills do you hope they develop in the first year? And what metrics determine the success of a candidate after a year? So let me jump back to the PowerPoint and see how much of that we have. Yeah, I think we got all that here. So let me bring this back up. So here are the questions in their entirety. Maybe you could share a few things. It'd be great. So Daniel, I take it that Monaco is an attractant, not a deterrent to getting data science talent out there. We had one company that they were in the Alps. I think it was in the Alps of Italy, and that was like their main thing, was to get people to come. It worked. They got a lot of people there. Yeah, pre-COVID. Yeah,
One day we'll get back.
Yeah, we will. We will. This is going to be the best New Year's ever. I don't know if hopefully 2021 is going to be as I'm advertising it in my mind, but it can't be worse. Well, it could be.
Knock on wood.
Yeah, knock on wood. Yeah, public sector. I mentioned in the intro that I worked in public sector for a lot of my practitioner time. I loved it. The use cases there are so interesting, and they have such immediate impact that it's really fun.
I'm interested in this question about outsourcing data science, but I don't know if we want to bite it off just yet. It's a little bit of a tangent to where we're talking right now.
We might have some time for it because I built in a lot of time for these little workshops, the breakout sessions here, and because we're virtual, we probably won't chew into all of it. So go ahead, throw out your question or your comment.
Well, so I mean, I've struggled with how to bridge internal and external data science talent for a while, and one of the things that I think a lot of us articulated in the chat early on in this conversation that one of the biggest problems with getting data science up and running in a business is establishing those good use cases in the first place. And one of the things that's hardest to do is to outsource to data science externally if you don't already have a good use case and you don't have a well-defined problem. And so there's kind of 2 options then. It depends on what kind of outsourcing data science talent you are doing. If you're hiring someone to be like in a true consultative fashion, come in and examine my business and help me understand where I have opportunities, I think that can be a genuinely good way to kind of like kickstart and get things moving. I think if you're hiring just like you want more sets of hands to get stuff done and you need to deliver more things, I think you can do that with outsourced data scientists if you have internal data scientists to help guide the process, because you still need somebody doing that translating between like the internal domain knowledge and the implementation and ability to actually get it consumed out at the end of the day. And somebody who's internal is going to have a lot more visibility to what all those constraints are and what part of the problem are relevant than an external person coming in and trying to ramp up is going to be. And so I have seen it work all right, where if you have a few internal data scientists who are pretty senior and can direct other people's work, that you can outsource some of the getting it done to external data scientists, and that can work. But it also is a little fraught with then they're effectively you're allowing your business to be open to all of these external pitches from other data scientists that are basically going to disagree with what your internal data scientists say, because they're not going to know all of the constraints and ins and out of your business, but your internal data scientists will. And so they'll promise you things that can't actually be done. And then that sets the internal data scientists up for really either uncomfortable conversations or failure. And those are kind of toxic to the sustainability of your data science practice. So you kind of have to like put some ground rules in place, I would say, about how you engage with outsourced data science talent to be able to kind of weave through those obstacles. It can be done and it can be useful, but you have to just know in advance that it's possibly going to cause some of this conflict. And so just heading that off and establishing what the ground rules are is really helpful.
Yeah, take some strong management.
Yeah.
Won't be successful otherwise.
Yeah.
Some good comments in here, looking for basic skills and knowledge, and then going in for soft skills after that. Yep. Collaboration with the university and researchers. Yeah, I've seen that work really well for organizations. I've seen large organizations that will intentionally put a office headquarters near universities for that reason, and then they reap a lot of benefits from data science talent, both in hiring that pipeline of new talent coming, but also in research ideas and having some consultancy from professors. Yeah, definitely seen a lot with that.
Mm-hmm. Yeah, UT has a really good relationship with Dell, and so we get a lot of capstone projects. People who they'll spend the entire spring semester of the end of their program working on a project related to Dell data, but it's managed and coordinated by the faculty, and so it's like really basically free work for us, and so it works out really nicely. Yeah, and then it gives us a good into hiring potential talent, because if they turn out to be really great to work with and deliver really great results, then we have them on our radar already.
Yeah, it's really nice to have a pipeline for
Yeah.
talent. Yeah. Then Tanya mentions emphasizing soft skills because hard skills can be taught. Yeah, great.
Yep.
Okay, let me mention a few thoughts on technology. We hit on this briefly earlier. To me, the three things we need to hold when we're evaluating technology to build an organizational capability, to build a data science flywheel, are one, collaboration, where you have an ability to have a shared context in the process of work. You can have a discussion that's captured with your data science teams, and you have that knowledge management. So technology can help with knowledge management for search and discovery and capturing those assets. The second is reproducibility and reusability. There's a lot of you might have seen articles about this in industry about being able to reproduce results with data science models. And I hold it as code, data, and environments, and then of course results as well. But you need those three things. You need the code, the data, the environments to be able to reproduce what you've done in the past. If one of those is out of sorts, you're not going to be able to reproduce those results. And then last would be agility and iteration. So this could be DevOps, this could be Kubernetes and Docker, this could be take a couple different forms, but being able to be agile, to iterate quickly, to experiment, some type of experiment tracking technology. There's quite a few options for those these days. And the ability to deploy quickly too. So not only DevOps, but model ops, being able to put things into production quickly, being able to limit the amount of friction between data science and IT, is huge to, technology can really help with that and is huge to developing that organizational capability. This is two slides of a shameless pitch for what Domino brings to the table. One, Domino wants to handle that DevOps, handle the model ops, do it in a way that's open on any cloud platform or on-prem, and give data scientists the tools that they want to use, that they know and love, like Jupyter Notebooks, RStudio, even integrating with proprietary tools like SAS and MATLAB. So data scientists can collaborate quickly, can deploy their models quickly. So data scientists get the cupcake. And this is a fun slide. And then on the top, those are not sprinkles, those are pills. So while the data scientists are eating their cupcake and loving life, at the same time, Domino makes it easy to do what's right. And I'm stealing that from you, Randy. I love that. I heard you say that one time. You make it easy to do what's right. Domino automatically versions the code, automatically keeps track of data lineage, allows you to be able to have that instantaneous reproducibility because it keeps track of Docker snapshots over time. And so you run a job, is 2 months later, you're like, oh my gosh, everything's broken. How do I get back to that previous state? It's right there in Domino. You click it and you're up and running. Domino is organized into 3 sections. There's a workbench, the collaboration hub, and then the model ops for deployment. So that's it on the Domino. Not much of a pitch, but just wanted to mention that is some of the problems that Domino is trying to solve for both data scientists and data science leaders as well. So in summary, what have we talked about today? What have we gone over? We've talked about data science. In order to be successful, it's not a single player mode game. It is a team sport. And as leaders, we have a lot of influence in the success of treating data science like an organizational capability. It will take some education of executives. It will take a lot of talking. It will take a lot of work, a lot of collaboration, but we have the ability, we're in the seats to make that happen. Alignment and partnership across your internal organization is crucial. You got to play politics a little bit. You have to get some quick wins. You have to show the feasibility of data science within the organization, but eventually you build up to having a really solid embedded seat at the table of your organization.
Unless you're like Daniel and you work for some hacker group. And then you can just like slip it in however you need to.
There you go. I love it. We talked a lot about process, and the main thing, I think the main takeaway there is really enforce a pre-flight checklist and define that pre-flight checklist. We'll send these slides out and you can have a lot of the ideas in these slides for what you want to include in your pre-flight checklist, but do the work up front, engage the stakeholders, engage the business, engage IT. Don't go off in a corner and just treat this like a kind of mad scientist type of work in the basement. Make this front and center and integrate that process. Then we've talked a lot about people. We've talked about developing and hiring and onboarding plans. We have talked about how to assess and how to attract talent, how to organize it. So there's obviously being a people manager is a big part of what we do, and very critical to the success of this overall initiative. And then lastly, we mentioned technology, some principles for technology, collaboration, agility, and then being able to have that reusable knowledge and reproducibility. All right, so here is my email, josh@dominodatalab.com. You can shoot me an email and I will send you the slides. We also have a white paper on that goes a little bit more in depth than what we were able to cover in just 2 hours today into some of these principles and practices that are about managing data science in the enterprise. I'd be happy to send you that if you'd like. We also have some example projects and some examples of how to organize projects up on our trial site. So you can go to dominodatalab.com/try and you get a 2-week trial there, and you can check out how we think about the world, how we organize projects, how we define the data science lifecycle, how we integrate it together and such. So thank you so much for being here today, Randy. Thank you so much for joining. Do you have any concluding thoughts in summary, Randy?
I just I love this topic. I've been really passionate about it for years, and I appreciate the chance to get to come and spend a couple hours with all of you. It's been a really good discussion and lots of good points that everyone has brought out. And so thanks for. I find it very validating to know that I'm not alone in having these kind of issues and hearing about other orgs also facing those problems. So uh, this has been great for me as well.
Yeah, and ditto and thank you to everyone for the chat. That really made it more useful. And actually, the virtual didn't work out bad at all. We had a lot more chat than we would if we did it in person. So thank you, everyone, and look forward to getting your emails and connecting on LinkedIn if you'd like as well.
Yeah, absolutely.
Yeah. Okay. Thanks, everybody. Have a great
Thanks,
day.
everyone. Y'all have a good day.